Welcome, my friends. In this video, I will be introducing and using the double and half angle identities for sine, cosine, and tangent. First, recall the sum identity for sine. Sine of x plus y is the same thing as sine of x times cosine of y plus cosine of x times sine of y. Suppose that x and y were the same. If that were the case, we could replace every y in the formula with an x. We would get sine of x plus x is equal to sine of x times cosine of x plus cosine of x times sine of x. On the left-hand side, we would have sine of 2x. On the right-hand side, both of these terms are the same, just with the order switched around. Of course, that doesn't make any difference for multiplication, because multiplication is commutative. So therefore, the right-hand side is 2 times the sine of x times cosine of x. This is our first double angle identity. Sine of 2 times some angle is equal to 2 times the sine of x times cosine of x. Now, if you use the exact same process for cosine, using the sum identity for cosine and letting y equal x, you will get a second formula. The double angle identity for cosine is that cosine of 2x is equal to cosine squared of x minus sine squared of x. Now, there are actually two more identities that we can derive from this identity. We know based on the Pythagorean identity that cosine squared can be written as 1 minus sine squared, and that sine squared can be written as 1 minus cosine squared. I'm not going to show all the work here, but if you plug in those values into this formula, you will get two additional formulas. You will get that cosine of 2x is also equal to 1 minus 2 times sine squared of x, and 2 cosine squared of x minus 1. Finally, if you let x and y be equal in the tangent sum formula, you will get tangent of 2x is equal to 2 times the tangent of x divided by 1 minus tangent squared of x. Altogether, these are the 5 double angle identities. There are also half angle identities, which relate to some angle over 2. The half angle identity for sine, or sine of x over 2, is equal to plus or minus the square root of 1 minus cosine over 2. Note that the plus or minus does not indicate that there are two answers. There will only be one answer, which is determined by the quadrant of x over 2. For example, sine is positive in quadrants 1 and 2, so if x over 2 is in either quadrant 1 or 2, then we will only take the positive square root. If we are in either quadrant 3 or 4, then sine would be negative, and we would take the negative square root. The half angle identity for cosine is very similar. It's exactly the same except for we have 1 plus cosine in the numerator rather than 1 minus cosine. The same idea applies to the plus or minus. You should use the plus when x over 2 lands us in a quadrant where cosine is positive, such as quadrants 1 or 4. You should use the negative when x over 2 lands us in a quadrant where cosine is negative, such as in quadrant 2 or 3. Finally, there are 3 half angle identities for tangent. We have tangent of x over 2 is equal to plus or minus the square root of 1 minus cosine of x divided by 1 plus cosine of x, or sine of x over 1 plus cosine of x, or 1 minus cosine of x divided by sine of x. I typically opt for the second or third identity because I don't like having to worry about using the plus or minus. If you wanted to use the first identity, then you would know that you should take the positive square root where x over 2 lands us in a quadrant where tangent is positive, such as quadrants 1 or 3, and you should use the negative square root in the quadrants where x over 2 lands us in a place where tangent is negative, such as in quadrants 2 or 4. Let's take a look at some problems working with these identities. We are asked to simplify cosine squared of pi over 10 minus sine squared of pi over 10 using trigonometric identities. If you're looking back at your list of identities, this looks very similar to cosine of 2x. One of the 3 forms of the identity for cosine of 2x is cosine squared minus sine squared. In our case, x is equal to pi over 10, which means that 2x is equal to 2 pi over 10, or pi over 5. That means that cosine squared of pi over 10 minus sine squared of pi over 10 is just the same thing as cosine of 2x. Since 2x is pi over 5, we have cosine of pi over 5. Now, of course, pi over 5 is not a commonly known angle, so we can't evaluate this, but this has simplified our expression. Let's try simplifying 2 times the tangent of theta over 4 divided by 1 minus tangent squared of theta over 4 using trigonometric identities. Basically what you should do is just look at your list of identities and find one that matches what we have in our problem. In this case, we know that tangent of 2x is equal to 2 times the tangent of x divided by 1 minus tangent squared of x. In our case, the angle x is equal to theta over 4, which means that 2x, which we need in our double angle identity, is 2 theta over 4, or just theta over 2. That means that 2 times the tangent of theta over 4 divided by 1 minus tangent squared of theta over 4 can be written as tangent of 2x. But 2x is just theta over 2, so that means that our answer is tangent of theta over 2. 2 times the tangent of theta over 4 divided by 1 minus tangent squared of theta over 4 is the same thing as tangent of theta over 2. Let's try this problem. We are asked to simplify cosine of pi over 8 using trigonometric identities. Now, pi over 8 is not a commonly known angle on the unit circle, but it is half of the angle of pi over 4, which is a commonly known angle. We can use the half angle identity for cosine, which tells us that cosine of half of some angle, or some angle over 2, is equal to plus or minus the square root of 1 plus the cosine of x divided by 2. Note that x in the formula is double the angle that we see in our problem. So if our angle of x over 2 is pi over 8, then double that must be pi over 4. So this becomes cosine of pi over 8 is equal to plus or minus the square root of 1 plus the cosine of pi over 4 divided by 2. Make sure that the angle on cosine inside here is double the angle of what you had on the outside. Pi over 8 times 2 is equal to pi over 4. Now remember that for the half angle identities, we don't have two answers. We only have one answer, which is determined by the angle of x over 2. Pi over 8 puts us in the first quadrant. Cosine is positive in the first quadrant, so we only need the positive square root. Pi over 4 is a commonly known angle on the unit circle, and cosine of pi over 4 is the square root of 2 over 2. If we multiply the numerator and denominator by 2 over 2, we will get 2 plus the square root of 2 over 4. 2 times 1 is equal to 2, and 2 times the square root of 2 over 2 cancels the 2's, which is why we have 2 plus square root 2 in the numerator, and 2 times 2 is equal to 4, which is why we have 4 in the denominator. The square root of 4 is just equal to 2, so we have the square root of 2 plus the square root of 2 divided by 2. This might look a little bit strange, but this is the exact expression for cosine of pi over 8. Let's try another problem. We are asked to simplify tangent of 7 pi over 12 using trigonometric identities. Again, 7 pi over 12 is not a commonly known angle on the unit circle, but it is half of a commonly known angle. 7 pi over 12 is half of 14 pi over 12, and 14 pi over 12 would reduce to 7 pi over 6. 7 pi over 6 is a commonly known angle on the unit circle. So we need to use the half angle identity for tangent. Tangent of x over 2 is the same thing as 1 minus the cosine of x divided by sine of x. There are actually 3 options for tangent of x over 2, and it doesn't really matter which one that you choose. X will be an angle that is twice as large as the angle on the inside of tangent. X over 2 is 7 pi over 12. That's the angle that we see on the inside of tangent. X must be double x over 2, which is 14 pi over 12, which reduces to 7 pi over 6. That means we can rewrite tangent of 7 pi over 12 using the formula. We have 1 minus cosine of x, which is 1 minus cosine of 7 pi over 6, divided by sine of x, which is sine of 7 pi over 6. 7 pi over 6 is a commonly known angle on the unit circle. The reference angle for 7 pi over 6 is pi over 6. Cosine of pi over 6 is the square root of 3 over 2. But at 7 pi over 6, we would be in quadrant 3, to the left of the y-axis, where cosine would be negative. So we will have negative square root 3 over 2. So the numerator becomes 1 minus negative square root 3 over 2. Again, the reference angle for 7 pi over 6 is pi over 6, and sine of pi over 6 is 1/2. Since we are in quadrant 3 with 7 pi over 6, we will not have 1/2, but we will instead have negative 1/2, because sine is negative in quadrant 3. Simplifying, we will have 1 minus negative, which becomes 1 plus the square root 3 over 2, divided by negative 1/2. Let's get a common denominator on the terms in the numerator. We can rewrite 1 as 2 over 2. so that we have 2 over 2 plus the square root of 3 over 2 divided by negative 1/2. Combining the fractions on the numerator, we have 2 plus the square root of 3 over 2 divided by negative 1/2. We can reciprocate the denominator and multiply so that we get 2 plus the square root of 3 over 2 times negative 2 over 1. The 2's will cancel, and we will have 2 times the square root of 3 times negative 1. If we distribute the negative sign, we will get negative 2 minus the square root of 3. Tangent of 7 pi over 12 is the same thing as negative 2 minus the square root of 3. Let's try to simplify sine of 2 pi over 9 times cosine of 2 pi over 9 using a double angle identity. Hopefully you recognize this as the double angle identity for sine. Sine of 2 times some angle is the same thing as 2 times the sine of x times the cosine of x. We have a slightly modified version of the right-hand side in our expression. We don't have 2 times sine of x times cosine of x, we just have 1 times sine of x times cosine of x. If we divide both sides of our identity by 2, we will get 1/2 sine of 2x is equal to sine of x times cosine of x. Now the right-hand side of our identity matches our expression. In our case, x is equal to 2 pi over 9, which means that 2x, which we need on our formula, is equal to 4 pi over 9. That means that sine of 2 pi over 9 times cosine of 2 pi over 9 is the same thing as 1/2 sine of 2x, or 1/2 sine of 4 pi over 9, since 2x is equal to 4 pi over 9. This is our final answer. Let's try a more challenging problem. We are asked to find sine of 2x, cosine of 2x, and tangent of 2x if sine of x is equal to negative 2 over the square root of 5, and x terminates in quadrant 4. Here is a reminder of the double angle identities for sine, cosine, and tangent. If we know sine of x, cosine of x, and tangent of x, then we can solve for any of the three identities. So far, we know sine of x. So we will need to find cosine of x and tangent of x. We can do this by drawing a triangle in the fourth quadrant. We are told that x terminates in the fourth quadrant, so we can think of x as the interior angle of the triangle. Technically, x is the angle that goes all the way around the circle until we hit this line right here, but it's easier to think of x as the interior angle of the triangle. Everything will work out as long as we consider which quadrant we are in when assigning the side lengths of the triangle. Let's work with this triangle on the side. We are told in the problem that sine of x is equal to negative 2 over the square root of 5. We know that sine is opposite over hypotenuse, so the opposite side must be negative 2, and the hypotenuse must be the square root of 5. We know to attach the negative sign to the opposite side because we are in quadrant 4, where the y-coordinate is negative. We need to solve for b so that we can find the remaining trigonometric ratios. We need to find tangent and cosine, and tangent is opposite over adjacent, and cosine is adjacent over hypotenuse, so both of those will use b. Let's use the Pythagorean theorem. We have negative 2 squared plus b squared is equal to the hypotenuse squared, or square root of 5 squared. Simplifying, we have 4 plus b squared is equal to 5. Subtracting 4 from both sides, we get that b squared is equal to 1. If we take the square root of both sides, we get that b is equal to plus or minus 1. Since we are in quadrant 4, and b represents the x-coordinate, we must take the positive square root, since x is positive in quadrant 4. We can put b equals 1 onto our triangle. Now we can solve for cosine and tangent of x. Cosine of x is adjacent over hypotenuse, or 1 over the square root of 5. Tangent of x is opposite over adjacent, or negative 2 over 1. If this was our final answer, we would want to rationalize the denominator for cosine. But our goal is to find cosine of 2x, not cosine of x, so I'm not going to waste my time at this stage rationalizing the denominator. At this stage, we are ready to plug into the sine, cosine, and tangent double angle identities. The sine double angle identity is sine of 2x is equal to 2 times the sine of x times cosine of x. Sine of x is negative 2 square root 5, and cosine of x is 1 over the square root of 5, so let's just plug that into the formula. If we simplify this, we will have 2 times negative 2, which is negative 4, and then the square root of 5 times the square root of 5 in the denominator, which is 5. Together, that makes negative 4 over 5, so sine of 2x is negative 4 over 5. There are 3 double angle identities related to cosine. One of those three is that cosine of 2x is equal to cosine squared of x minus sine squared of x. Cosine of x is equal to 1 over the square root of 5, so cosine squared of x is 1 over the square root of 5 squared. Sine of x is negative 2 over the square root of 5, so sine squared of x is negative 2 over the square root of 5 squared. Squaring the first term, we have 1 over 5. Squaring the second term, we have 4 over 5. We still have the minus sign in the middle, so we have 1 over 5 minus 4 over 5. 1 minus 4 is negative 3, so we have negative 3 over 5 for cosine of 2x. Finally, we need to find tangent of 2x, which is equal to 2 times the tangent of x divided by 1 minus tangent squared of x. Tangent of x is equal to negative 2, so we have 2 times negative 2 divided by 1 minus negative 2 squared. 2 times negative 2 is negative 4, and 1 minus negative 2 squared is 1 minus 4. 1 minus 4 is negative 3, so we have negative 4 over negative 3. The negatives cancel, and we have 4 over 3. Tangent of 2x is equal to 4 over 3. We have finished our problem. Let's try one final problem. We are told that sine of theta is equal to 5 over 13, and that theta is between 90 and 180 degrees. We are asked to find the values for sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. Here is a reminder of the half-angle identities for sine, tangent, and cosine. As long as you know cosine of theta, you can actually solve for all three identities. We are told sine of theta, so all we need to do is find cosine of theta, and we can solve for all three identities. We are told that theta is between 90 and 180 degrees, which tells us that theta is in quadrant 2. Let's draw a triangle in quadrant 2. Let's work with this triangle on the side. We are told that sine of theta is equal to 5 over 13. That means that the opposite side is 5 and the hypotenuse is 13. If we want to find cosine of theta, we need to find the adjacent side, which we will label as a. Let's use the Pythagorean theorem. 8 squared plus 5 squared is equal to 13 squared. This simplifies to a squared plus 25 is equal to 169. Subtracting 25 from both sides, we have a squared is equal to 144. Taking the square root of both sides, we get that a is equal to plus or minus 12. Since we are in quadrant 2, and a represents the x coordinate, we should take the negative square root. So a is equal to negative 12. We can put this value onto the triangle. Cosine of theta is adjacent over hypotenuse, or negative 12 over 13. At this stage, we are ready to solve for our half-angle identities. We know that sine of theta over 2 is the same thing as plus or minus the square root of 1 minus the cosine of theta divided by 2. Plugging in cosine of theta, which is negative 12 over 13, we have plus or minus the square root of 1 minus negative 12 over 13 divided by 2. Let's take care of the plus or minus. Recall that for the half-angle identities, there is not two solutions. There's only one solution, which depends on the quadrant of theta over 2. We are told that theta is between 90 and 180. That means that theta over 2 must be between 45 and 90. So theta is in quadrant 2, but theta over 2 is in quadrant 1. Sine is positive in quadrant 1, so therefore we only need the positive square root. 1 minus negative 12 over 13 is the same thing as 1 plus 12 over 13. If we get a common denominator in the terms in the numerator, we have 13 over 13 plus 12 over 13. 13 plus 12 is 25, so we have the square root of 25 over 13 divided by 2. We can reciprocate and multiply so that we have 25 over 13 times 1 over 2. 13 times 2 is 26, so we have the square root of 25 over 26. The square root of 25 is just 5, so we have 5 over the square root of 26. We can rationalize the denominator by multiplying by the square root of 26 over itself to get 5 times the square root of 26 over 26. Sine of theta over 2 is equal to 5 square root of 26 over 26. Let's try cosine of theta over 2. Cosine of theta is equal to negative 12 over 13, so we have the square root of 1 plus negative 12 over 13 divided by 2. I've dropped the negative square root since we know that theta over 2 is in quadrant 1, so cosine will be positive. This becomes 13 over 13 minus 12 over 13 if we get a common denominator on the terms in the numerator. 12 minus 13 is just 1, so we have 1 over 13 divided by 2. So we have the square root of 1 over 13 divided by 2. If we reciprocate the denominator and multiply, we have 1 over 13 times 1 over 2. This is the same thing as the square root of 1 over 26. The square root of 1 is just 1, so we have 1 over the square root of 26. Again, we can rationalize the denominator so that we get the square root of 26 over 26. Cosine of theta over 2 is the square root of 26 over 26. Finally, tangent of theta over 2 is the same thing as 1 minus cosine of theta divided by sine of theta. There are 3 options for tangent of theta over 2, and I've just chosen one of those 3. Cosine of theta is negative 12 over 13, and sine of theta is 5 over 13. So we have 1 minus negative 12 over 13 for cosine divided by 5 over 13 for sine. Getting a common denominator on the terms in the numerator, we have 13 over 13 plus 12 over 13 because the negatives cancel each other. 13 plus 12 is 25, so we have 25 over 13 divided by 5 over 13. Reciprocating the denominator and multiplying, we have 25 over 13 multiplied by 13 over 5. The 13's cancel, and we have 25 over 5. 25 over 5 is the same thing as 5, so tangent of theta over 2 is equal to 5. Alright, my friends, that finishes introducing and practicing using the double and half angle identities.